Okay, so we are on the last question of chapter 4. So it's question 4H7. Before running this code, make sure that you've used these first two code blocks to install and load in the Rethinking package. And also something I often forget to mention is that if you're running this in Colab, make sure that you're up here in runtime. And if you go down to change runtime type, your runtime type is R, and the reason that's important is because it defaults to Python. So if you're running this in R, then make sure that you have selected R here. Okay, so this asks us to revisit a model that was earlier in the chapter and also in earlier questions, and that is to go back to the cherry blossoms data, and we are using once again a Bayesian spline to model DOY. Okay, and DOY is the day of the year at which the cherry blossoms are blooming, and we're modeling DOY as a function of year, and we'll go through this code here in a second. And what it asks us to do is to omit the intercept A or alpha, and to see what happens and to see what else we need to do in order to make that model run. Okay. So let's just go up to, I think it's 6. Is it 6? Yeah. So this is the model that we are looking at right here. Okay, and we looked at this in question 4H6, but it's also in the chapter. Okay, and let me just walk through all of this code because it's basically duplicated in the next question, the one that we're working on, with the exception of this little bit right here. Okay, so so first I want to call the cherry blossoms data, and that's part of the Rethinking package. I'm going to call that data frame D, and then I'm just selecting the cases, the rows of the data frame D, where we have a DOY value. Okay, and I'm calling that D2. Next, I'm going to start defining my basis splines. Okay, again, look at earlier videos for this. If you're not really familiar with the basis splines, or better yet, read the chapter. So I'm going to load spline package splines, and then with the command BS for Bayesian splines, I'm going to build a spline for D2 year. That's the thing that we will be regressing on in the model. And I'm going to define knots, and this is just little fixed points along the different values of year. Okay, and I'm going to define my knots here. Okay, so I have 15 knots, and I'm going to space them along the year, along the x-axis here, which is right here. And I'm going to use a third degree, a cubic polynomial for the knots, for the splines. Okay. Now, what's important here? So this is the model. Okay. So we took DOY and I called it D. Okay. So down here I'm defining the data that I'm using. I have B and DOY. Okay. And I'm defining it as a normal distribution with mean mu, standard deviation sigma, and then I'm regressing mu on an intercept A or alpha that has this prior distribution, as well as my splines. And again, my splines are just they're using year as the model. So I'm regressing on year, but I'm kind of using a modified variable year, and it's B, and it's the spline on year. And then I'm looking for the parameters W that multiply B in order to make the model fit the data. Okay, and so what we're asked to do here is to omit the intercept. Okay, so this will no longer be there. So let's go back down to our model here. So all of this code should be identical from above, and let's I've already done the things that I need to do in order to make that work. Okay, so but notice now that we don't have an A. Okay, and so we are just modeling mu as a function of the basis splines, as a function of year, but now we don't have an intercept. Okay, so I'm going to try to run this. Okay. And this one actually runs, which is interesting. Okay, so I just paused and ran it again because it did something that I did not expect it to do. But this is what typically happens. So when the model runs, there's a little bit of a stochastic process, but the result of that stochastic process generally is that you'll get a warning such as the model may not have converged, that maximum iterations have been reached, and several others. And so basically what this is saying is that, okay, yeah, we got estimates, but they may not be that good. And in fact, you see another warning sign here, which is that we have not a number of values for sigma. So what do we need to do? What have we done? Well, what has happened is that when we go, so what has happened is that we know already that so we see that our data is really clustered around 110, okay? And that conceivably was being taken care of by the intercept, right? The intercept, again, is the value of the y variable when this other stuff is 0, okay? And we guessed that a here was going to be about 100, and then when the model ran, it probably found a value closer to 110 or something, okay? But now we don't have that intercept. We don't have anything to push the average value up to 10. All that we have are these basis splines, and we're on average multiplying them by 0, right? So that means when all of our basis spline values, or when all of our w values are 0, making this entire term 0 or close to 0, okay, then there's nothing to push our average value up towards the actual average value, which is about 110. And so what we need to do is we need to get these basis splines to, quote unquote, take up the slack of the missing intercept. And so the way that we can do that is to put this up, is to put the w values up, to boost them up. I'm putting it to 100, but it probably doesn't need to be that high. And just for clarity in my code, just to show that I have omitted the intercept, I'm going to put 0 in here. Okay, so now I'm going to run this code, and again, all I've done is I've taken up the slack of the missing intercept, okay, by adjusting w here, okay, the prior for w. Okay. And now we see that there should be no problems running this particular bit of code, and we get estimates for all of them. Okay, I wish I would have pointed it out, but earlier, not only did we have sigma values that were NaN, this was, I think, 900, and most of the w values were around 1. Okay, so anyway, that is the solution to the last question here, 4H7.